But we are on a stream right now. Oh my goodness. This is gonna crash my stream. This is gonna crash my stream, but whatever. No! Oh my goodness. So we just got this exercises. Let me see if I'm streaming YouTube right now. Katie Marys. Yeah, I'm streaming. I forgot. Oh my goodness, this is gonna be so freaking insane. Operation, which means it operates only with two elements, so to evaluate an expression involving symmetry difference among three elements A, B, C, you must complete the operation at one time. Thus, for the sets A and B above, alright. When a function takes two or more arrays and return an array of either geometry. Oh my god. What is symmetry difference? No. Can I use AI? Oh my goodness. So it's gonna be 2 hours of suffering, but whatever. Can I use that? Bro, what is freaking man? So break this down. With the function map count occurrences for each element. No, we're gonna use cloud. This is gonna be so cringe. Yeah, we don't know. Got it. bro. The rest, bro. Pass any number of arrays and separate arguments. Freeze must be counted across all arrays combined. How many times did you show up? Wait. Each value appears across all arrays. Tricky from your previous code doesn't work here once you have the tree. Plus arrays, let's be step by step. Okay. So the step 1 is 1%. So I'm gonna make a page for this. Separately, I think. So these 2 pages. It is symmetry difference exercise. I don't know how much pages it's gonna take, but I'll try to take the maximum pages I can. Symmetric division is defined between 2 sets at a time. But for 3 arrays, you don't compute on global appears once. You change the binary operations left to the right. How? This matters because the enemy can cancel out and then come back to take your test 7. How did this break it? Shouldn't have any both A and B. They have removed it. So repeated number is gonna be removed, and 3 cancels with the C. So 3 appears. No, 1 appears in the C. So it's gonna be 3, 4, 5. I don't think so. So let me copy this. So the symmetric difference between A and B is 3 because let me see it. 1 appears in A, 1 didn't appear in A, 2 appears in A, 2 appears in B, 5 appears in B, 5 appears in A. So the only numbers that are set here is 1 and 3. What if I change my camera? No way. So I have to break it down this exercise into what I have here. I have that one appears in A and B, and eliminated the rest of them. So 5 appears in a B, 5 appears in A, 2 appears in a B, 2 appears in a A. So we stay with 1 and 3, and the symmetry of difference and the rest of this with C, we're gonna have. So we have 3 and 1. 3 is eliminated, so we stay with 1, 4, and 5. One more. So we have 3 concepts of C, but 5 can almost be cut back because it wasn't in the intermediate result. If you would just count around accuracies of 5 across all the 3 arrays, you get it 3 odd, but not exactly 1. And native keep count equals 1 filter would wrongly drop it. The real rule for chain operator turns out to be oh my goodness, that'll be for each array. Bro. Dedoob. Has to be dedoob. Array first, then keep the values whose total accuracies across the arrays is odd. Not exactly 1, but the cleanest way to implement it and the way that matches the math definition is to write to array version first, then chain it. So easy version first. Symmetric difference of exactly 2 arrays. This is the building block for everything. Also depends on for 2 arrays A and B. That'll be each array, so internal duplicate is like 3 to 3, don't mess it up. Counting a value belongs in a result if it is A but not B, or B but not A. I don't understand this. Let's play again. So easy versions, symmetric versions of exactly 2 arrays. I have to remove one of these elements, and number 2 value belongs it is rule with A but not B, or B not A. What is this So we're gonna have 2 sets right here and results. Set A for each value, and in this set, if set B has value that is inserted on set B is different, as is in A only, B only, or whatever. value belongs in a result if it's in A but not in B, or in B not in A. So we have this difference set A, we have this new set, you have the result. So we have 2 for each set. And let me see it. So if the set B has value result push value 1, if not, my goodness, this if is one line if. Explain this better. Wait. Let me get up. So we're gonna have this function. We can understand this and the return result, which is array. This is the heart of 2 arrays of symmetrical geometry. Let's lower it down. We were working with, by the time we reach this code set A, set B, and already the set objects, the person of the 2 arrays of set gives us a first dot value has value. Check this value in here, yes or no, which is exactly what we need to test membership. The first block finds values in A, only in A. So we have this first block find values only in A. So yeah, let me write this up. Set A dot for each value, arrow sign, curly braces, curly brackets, I don't know. But now we have a one line if condition. If negative the set B that dot has value result push. What is this push mean? Set B I don't understand a thing. I really don't understand something. Result dot push. Like this. If set B has value is true, the value is in both sets. It doesn't belong in a symmetric difference. Skip. This walks through every value in A one at a time and asks, does set B also have this value? I'm not gonna use this camera anymore. Just walk through every value inside A one at a time. That's does set B also have this value? So, wow. If set b dot has value is true, both of sets it does not belong in a symmetric difference. Just skip it. We don't add an array. The result vary. If set b dot has is false, so that has is true. The value in the but let's push into results. Oh my goodness, there's so much thing that I just played. So if set b if set b is true, the value is in both sets. It does not belong in a symmetric union. We skip it. If set b is false, so set b the value is true, the value is in A but not in B, it survives, it push to results. False. So set b has values false, so negative of false is true, the value is going to be added to the results. So second block, find any values on b. The same logic we already. Now we won't talk. We talk through set b and check either the value set a has each value. If the set a doesn't have it, the value executed should be the goes to result 2. Just inventory on. You're gonna have two difference of two sets. So we're gonna have difference 2 function of an array. The first array contains 1, 2, and 3. The second array contains 5, 2, 1, and 4. So the difference between this is gonna remove if the first one or is the second one, it's gonna be removed. If the third one is in the second one, so if 2 is in A and 2 is in B, it's gonna be removed too. And we just survive it with 5 and 4. So we have 5 and 4 left. In B but not A, the result is gonna be 3, 4, and 5. Oh, 3. I forgot it. 3. 3, 5, and 4. Matches the test in order aside. Extended to n arrays using reduce. Now that we have reliable two-arrays operation chaining across many arrays, it is just reduce. Function sync arrays. There's 3 points. What does that mean? Return arrays to reduce diff2. So we have another function that we can extend to any arrays that we want. Then we have reliable two-array operation chaining across many arrays is just reduce. So we're gonna have this function symmetric difference. I'm just gonna put the name of the function. Symmetric difference. 1, 2, 3 points. Arrays. What is this arrays? Where do you get it? Is this arrays? No, it's not here. Return arrays. What does this reduce mean? Find this function. Just if our initial value starts with 0 as a accumulator, then calls the two difference the next array for each remaining array exactly the the reduce. I'll explain this part. Have this. Let's show reduce way down. Size this. Doing more work here than it looks like the first glance. Which glass? What reduce actually is? Reduce takes an array and folds down into a single value by repeatedly applying a function to a any result. The emulator in the next item that general shape it is. Fold it down into a single value by repeatedly applying them. So it's the accumulator and the next item. The general shape is. Like functions for any result accumulator and then the next. Each call's return value becomes the accumulator for the next call by the end. You're with one final value. combine and then somehow, and also how many somehow. Accumulator, right? Each cause returns a value that becomes secondary for the next call by then you are left with one value. No pass and initial value. This is the part worth housing on. Boost normally takes a second argument and starting value for accumulator. Somehow you can combine them. How somehow happens. Each call returns a value that becomes accumulated for the next call. By the end, you are left with one initial value, one final value. And what is this final value? What happens when you don't pass the initial value? This is the part worth pausing on. It just normally takes a second argument and starting value for the accumulator. The hell, man? How did this work? But in arrays that reduce, if two, there's no argument when you will meet. Reduce falls back to a specific rule. Using array 0 as an initial accumulator and start for the iteration from array 1 instead of array 0. So it's not magic. It is just reduce filling the gap by borrowing the first element as a starting point, then looping over everything after it. What is borrowing?
Borrowing.
Borrowing. Borrowing the first element as a starting point, then looping over everything after it. Mapping that into our function. Here erases the list of arrays pasted into sim arrays, see how it counts. So what does this happen? Oh my goodness. Mapping that onto our function. Here erases the list of arrays passed into synchronous arrays, say someone calls sync ABC. Then ABC counting arrays that reduce this. Initial setup accumulator the first way was used as no function call yet. Step 1. To call it, you return some with a result called R1. New accumulator R1. Got it. We turn some horizontal calculator R1 new accumulator. R1 is gonna be, we're gonna compare result 1 with C returns result 2. New accumulator is gonna be result 2, and no arrays left. Those 2 returns with those 2. Fuck. Diff A and B, so we can compare A and B first. After compare A and B, it returns some result, call it result 1, the new accumulator. It is supposed to receive one value at a time. Initial setup accumulator A equals the first array uses at no function call yet. So call the diff function 2, return some result, call it a result 1. So we can just have the result if you have 2 arrays or more. That's the logic of symmetric arrays, but whatever. Return some result. After returning some result, we call it result 1. As is. Yeah, great question. Some result, and we're gonna call it R1. That stands for result 1 equals new accumulator of the results that is being storage on A and B, and we eliminated it. So alright, a reduce. What is the reduce function? Make an undefined single valued non-array of results, not a list of steps. It collapses or reduces the whole array down on the whole thing. Simple way to see it. So we have 1, 2, 3, 4, dot reduce, accumulated value, accumulated plus the value. This doesn't give you 1, 3, and 10. It really does, it gives just 10, the final number. After all additions are done, everything in between is internal. Only the last result comes out. One final single value, not an array of results. Just write this out. Wait a minute. Incredible. Incredible. So, oh my goodness. Can we resolve this? Reduce makes one final single value. Return one final single value. Another array of results, not a list of steps. It collapses or reduces the whole array down into one thing, one result. So, the reduce is something that is gonna reduce the array into one element. It's not battery element. So much element. Makes one final value, not an array of results. So it will be like that. We are not gonna have a list of steps. It collapses or reduces the whole array down to one thing. It reduces. The simplest way to see is we have an array of 1, 2, 3, 4, and dot reduce accumulator. We have all the counts of the elements plus the value of the elements. That's going to turn 10. We don't count each other, so it's going to be 1 plus 3 is 3, 2 plus 3. No, 3 plus 3 is 10, and 3 plus 6 is 9, but it's not 10. Where did you get that? So, this doesn't give you 1, 3, 6, and 10. It's gonna get you just 10. the final number. After all the addictions are done, everything between us is internal. Only the last result to come out. So we have this 1, 2, 3, 4. Reduce accumulator value is array function, arrow function, accumulator plus the value semicolon. The running total is give it 10. 1 plus 2 is 3. 3 plus 3 is 6. Plus 4 is 10. Okay, I understand it. We just get it all together. Sum it all together. 10. Have 10 right here. Just get result. The result. After all the addictions are done, everything in between is eternal. The only last result comes out. Arrays is a list of arrays like ABC. Reduce doesn't give you back ABC transformed and doesn't give you difference of two arrays and difference of two results. As a list of intermediate arrays, it gives you one single array, the very last accumulator. After all, thieves calls have happened. Let me see it. Does this course have course before this? I have the audio project in the coding interview prepare. What's the audio project stand for? No, it's not exercise. This is just a course. Coding interview preparation. Symmetry difference. So we have this. Arrays a list of arrays. Arrays start to reduce diff2. What is this diff2 which stands for? Oh my goodness, I'm gonna break this down into parts. So I'm gonna make this obsidian vault. What's the name of the exercise? Symmetric difference. So we're gonna start by doing this. Great problem. Is this entire full? No. Step 1. Understand the core operation. Gonna break this into small pieces. Oh my goodness. No. Great problem. The DAO uses defining between two sets at a time. But for 3 arrays, you don't compute the data on global address counter. You change binary. So if A and B, 3 and 2 and 5 are both in A and B, so they are removed. So we have 1 and 3. And the symmetrical difference we have is eliminating 2 arrays. 1, 4, and 5. 3 cancels with C, but 5 comes back because it wasn't in the intermediate result. If you just count it wrong, of course, it's a 5 across all the 3 arrays, you will get 3. Output exactly 1 and native keep 1. Computer results. Common values between, like, so we have common values. Let me remove. So common values. It's gonna be both. So common values. We have trees get odd. 4, 5. One more do we have? So the result is gonna be 3, 4, 5. Oh shit. Step 2. Solve the easy version of first. Symmetrical division is often exactly 2 arrays. This is the build block of everything that depends on for 2 arrays A and B. There will be each array, so internal duplicate is like doesn't mess it up. So I have step 2. So internal duplicate is like 3 to 3, don't mess it up. Counting a value belongs in an internal in the result if it's A but not in B, or B not A. Don't understand FA. Set a new set. So the diff2 function is gonna be like this. We're gonna have this function diff2, the difference of 2 arrays. Const set A new array, new set, and const set B new set. Const result. This is normal structure of this. So, great answer. Function difference 2. So this is the function diff2. A and B first. Forget that C, man. Forget. And this is for just example. Set A equals a new set. So it's starting from scratch. Let me start from scratch. Let me start from scratch. Yeah, boy. Say E goes to new set and receives the A. I'm gonna receive this A. semicolon com set B. B equals to new set, which is we are receiving the B, semicolon const result. Equals to empty array. So we have an empty array right here. Set A, for each value that is in set A and not in set B, we push to this value to where? Result the push value. Gonna push this to result array. So we just got the empty. It's an empty array. Set for each value that is in. No, I'm gonna have an if condition. Error function. Oh shit. If the set, if the value that is in the set B is not in the set A, we push the value that is in the set A to the result. If the value is negative in set, if the value that is in set B it is false and it is not in set A, we result dot push the value that is in set A. This is just for set A, I think. Fuck it. So it's gonna be like this. If the value is not in a set B and is in a set A, we just push it to result array, empty array. Set B, for each value that is on set B, if it was in the set A, we result dot push the value of the set B to the empty result array. Then we receive two arrays on this. have function difference of two arrays. I'm gonna call set array. The set A equals a new set, const set B a new set, and const result is gonna be a empty array. So set dot for each array, for each value that is porra. Set A dot for each value that is in the set A, and it is not on a set B. The value is gonna be pushed to the result away. Alright, let me code this. Function div2 is gonna be B. So let me remember this. Const set A. Have this set A equals new set. We have receiving. We are receiving this value. Const set B. We're gonna create a new set for the value B. Const result is gonna be equals an empty array. After all, we have the fuck set A for each value that is in the set A. Set A. We're gonna have this condition. It's an arrow function, but I don't know how to do an arrow function. Inside of this. It is inside of this. So for each, the fuck, man. What is this value came from? So we have creating a value of val, arrow sign, if set B dot what value has value. We do what? What the hell? Just going to make what? Bro, what is the word that is missing in this arrow function? Oh, we're missing this. What? Result dot push A. It is not result. Result, and it's the same thing for set B. So set B for each value. I have our function. Fuck. If the value that is in set A has value, we're gonna out of this if statement dot push B. It is val. Number shit. After all this, we just return the results. The hell, man! I haven't like JavaScript compiler. Code executed successfully. But what about my logic? What is this first screen? Div 2. Ah. Okay, maybe if I console.log this function. One and two. So 1 and 2 didn't appear on the B array. We're breaking down this part. So here's 1 and 2. Step 3, extend the number of array using reduce. The result of this is gonna be like no. The result's gonna be 1 and 2. So we have a 1 and 2 array of the result. As a result, the type of number extended and the number of arrays using reduce. Now that we have a reliable 2 array operation, chaining and Rosemania arrays is just reduce. So this reduce function is a shit. I didn't understand this at all at first. I have this percentages JavaScript. Why does they don't recognize it as a JavaScript? Whatever. Extend to an arrays using the reduce. So this is going to be inside of the diff function. Not. No, it's going to be outside of the diff function. So outside of this diff function, we're going to have this symmetric arrays. And these arrays can from what? Reduce, return arrays, I'll reduce div2. And that's 3 to 6 arrays. So just by created this small line of codes. Function symmetrically, we're gonna have 1, 2, 3 arrays. The 3 points. Inside of this function, we're gonna return arrays dot with this difference of between two elements. So we have to test 3 to 6 arrays, or test 9 to 10. If this is this, I create a function symmetric that's gonna receive n arrays, and we're gonna have the return arrays dot use div show console log sync function like these are there too. See, we just don't even array with an initial value. What am I doing wrong? Div2, it is right at F2. Dev2's. I make this. Execute it successfully. One more day of 4. 3. 1 and 2. What happened right here? Six, 7, 8, and 9. Bro, I didn't call the function, by the way. No. It was missing in closing parents. It is just breaking down. Reduce this in what? I have to put it div2 right here. One, two, three, five, 6. What does this stand for? If I put repeated values like 2, 3, But for one and one. Yeah, let me calculate this. So first one, I'm gonna have 1, 2, and 3. This is the 1 and 2 and 3. B, we have 1, 5, and 1. And for C, we just have it 2, 3, and 4. 2, 3, and 4. So have to eliminate it, the equals in the first one. So what is the equal in the first one? We have eliminated 1. We stayed with 2, 3, and 5. Eliminated 2, 3, and 5. With 2, 3, and 4. Eliminated 2, eliminated 2, eliminated 3, eliminated 3. We have eliminated 4, eliminated 4. What? It stays with 5. What is this gold doing? Wait, what? No way, guys. What the hell? Should return. So let me test it on my notebook. I'm gonna test this on my notebook. No way. I'm a so dumb. I'm so dumb, guys. I'm so dumb. I can understand this function. So we have A is gonna be 1, 2, 3. B should be. Let me see. Oh wait, guys. B stands for 5, 2, 1, and 4, and should return 345. And we have 1, 1 executed, 2, 2 executed, 3, 5, 4. He's asking ascending in order. So it is exactly, it is, we have 3, 4, and 5. Should have contain 3 elements. 1, 3, 3. Should have returned this. So I have 1 and 4s. Okay. Let me get the last one. It should have contained 8 elements. Should have returned. So we have this big one is gonna be the problem for me. 1. When I raise is gonna be like 3, 3, 3, 2, 5. For B we have 2, 1, 5, 6, 7. 2, 1, 5, and 7. Finish this. C 3, 4, 6, 6. D we have 1, 2, 3. For F we're gonna have 5, 3, 9, 8. 5, 3, 9, 8. And for G we have 1. So exactly we have to group by after the first one and the last one. No, it's the first one, then we have to the next and next and next and next. So in the first one we have 3, 3, 3. So the first one we have 2 and 2. Eliminated a 2. Should return. This should return 1, 2, 4, 5, 6, 7, 8, and 9. Alright. So we can contain this. I have 5, 5 eliminated. Which stands with a 3, 1, and 7. 3, 1, 7. This is the first round. So go ahead. We have 3, 1, 7 with 3, 4, 6, 6. 3, 4, 6, 6. Which stands with 1, 4, 6, and 7. Okay, second one was eliminated because we have 3 over here. 3. And after that, D. 1, 2, 3. 1, 2, and 3. Eliminated the 1. Then 2, 3, 4, 6, 7. After this, we will have this 5398 5398 with the result. If I code this by myself, so eliminated the 3 2 5 no 2 5 4 5 6 7 8 9, and for the last one we should have 1, so it's gonna be 1 2. Damn, guys. Should return. Exactly. 4 5 6 7 8 9. It is exactly this result. So it's the same logic that I can apply on. It was easy, man, but I was not able to do it. So I'm trying to do it by my hands right now. We got function div2 I receive a and b as a parameter. Open the curly brackets, const a. I have this a. Oh. Const a equals a new set. I'm gonna receive a. No, value. We're gonna create a value inside of this set. After this, const b. Whoa, is this new set correct? Whatever, I really don't know. It's gonna receive the parameter a. So it's gonna be av new const b equals to. Does it need to be caps lock? New set is gonna receive the parameter b. I don't think this is right. Set a and set b. What is wrong with here? It is missing semicolon. It's not missing semicolon. Equals so we're gonna have this function div2 a and b as a parameters. We're gonna receive values on this a and b. After that we have const declared 2 variables for this. So set a, which is a set of, is gonna receive the values, so it's gonna be a new set and we're receiving the value as a. Const set b equals new set for b values for the value that we're gonna receive on this b as is a parameter, and const result as an empty array. And we're gonna have for each, no, set a for each, which what value that is going to be what, I don't remember. Oh shit. I really don't remember. We're gonna receive the value, and after we receive the value we have what? I want to iterate. If set b that has value. So if the set b has the same value as set a, we gonna have the result of result dot push value. We're gonna it's only for a, so we're gonna return the value that is in a, whatever. After this I really don't know. The same for b, for each value that is on the set B, if the same logic is applied to here, set A has the same value as set B, we gonna print, no, if this is false, it doesn't have the same value as the set B, we gonna, no, result dot push the value of only for B, only B. After that, what is, I just said set B with minus B. What is wrong here? I was missing the parentheses in the end. Oh shit! Bro, what is wrong right here? Is that push? He's really missing this. What? No, try again. So, symmetric difference. We have this mathematical term, symmetric difference of two sets is a set of elements which either. So we're gonna do this exercise to find the symmetric difference of arrays, if it's A, B, C, or more arrays. Most of the arrays we want. So we're gonna start with a function. What is the name of the function? Difference of two arrays, whatever, or n arrays. Difference of arrays, and it's gonna receive A and B as the first parameter. Or we have to make the first one like here, just making this 2 first. So diff2. Oh miséria. Const set A for the set, new set A, const set B for the new set B. You're showing me up here. We're gonna receive the value that is in the parameter B. After that, we can declare the const result equals to empty array. Let's make this exercise once again. My goodness. I'm gonna have a function of the difference of two arrays, and this we are receiving the A and B as the parameters. So we're gonna have the const set A equals to new set as the value of the parameter A, const set B and new set 2. Nope. After this, const result, the result of the two arrays. After, what else we need to do? If conditions. But what if the value is in the B or is in A? We're gonna put this in the result of empty empty array. How can I do this? Set A for each value that is in set A. For value, that's it. For each value that is in set A, we're gonna return no. We'll have a if condition. If what? If what? If the value is not, if the value that is in set B is set B dot has, so we are obligatory, I don't know how to say this word in English, but we're gonna accept the value that is the same in the set B for the set A, and we gonna return return what? Return the value, return the result, return dot now result dot push. We're just gonna put this value on the result empty. And what is supposed to be? I just make it as value. What I made it wrong here?
Saying, you know, I like your work or whatever that is, and I would visualize things coming to me that I wanted or whatever. Drive home and think, well, I do have these things. They're out there. I just don't have a hold of them yet, but they're out there. I wrote myself a check for $10 million.
Maybe this is outside.
Myself, 5 years, 3 years, and I dated it Thanksgiving 1995, just before.
This is gonna be out this.
Thanksgiving 1995.
Yeah, definitely it is. So leave. Wow. So we're gonna do this exercise of symmetric difference. We have a function of the difference between two arrays. For this exercise, we're gonna receive A and B. Bro, this A and B is gonna be just two values because we have to first start with two arrays, and after this we have a function that is gonna add more arrays to this. So we are gonna have A and B, and const set A equals new set. We're gonna receive the value A. Const set B new set. We're gonna receive the value of the parameter B. No, come back. And we have a variable of the result because we want an empty array of putting the values of the set B and set A inside of the empty array of the result. So we're gonna have result as an empty array, and after this, what? What exactly would you have? We're gonna have. Oh my goodness, I didn't remember. Shit. If condition of what? For each value that is inside of the set A and set B. So set A dot for each value, and what value? Maybe I should do this arrow function. Inside this we have if the value that is inside the B is not equal to the value that is inside the set A. So we just have one this. No, it's not. It's not gonna have it inside. Has value. We're gonna, if the set B doesn't have the value that is inside of the set A, we're gonna bring it as a result of this if condition. What? No, we're gonna it's not return. Result dot push. We're gonna put this result. No, we're gonna put these values inside the result. Push value. So yeah, that's it. And set B for each value. The value. No. Value that is inside the set B. We're gonna do this if set A doesn't have the value of that set B. We're gonna make the same thing. Result dot push the value that is not in the set A and is in the set B. After all this, I think we can return the result. Return result. After this, we're gonna declare another function for any number of arrays, and like here we have A and B and C. Have A, B, and C. So return function. Because I don't remember this. Sync. We're gonna receive div2 different of two arrays. Man, I can't remember the difference of two arrays, and and what? Return. Oh, no, it's not a. It's gonna be a race. I'm gonna declare a variable, a parameter over here after a race, and I'm gonna return our race dot reduce div2. And why should we use reduce? I understand, but I don't understand. Why are you using? Why are we using point arrays and dot reduce? So why using dot arrays the rest parameter? The property statement says C must have 2 or more arrays, not fixed numbers. Sometimes 2, sometimes 4, 6, or more. But a number function signature has fixed a number of 9 parameters. Only works for 2 arrays. Only works for exactly 3 arrays. Neither of these is flexible enough. You would have to write a different function for every possible count of arguments, which is unworkable. My goodness. It's gonna take me 2 hours to finish one exercise of free code course of interview code preparing. The problem statement says syncs must accept 2 or more arrays. Sync must. So the parameter of the statement. No, the statements are parameters or whatever. Must accept 2 or more arrays. And why do you mean by that? Not a fixed number. So it is not a fixed number. More is not a fixed number. Not fixed numbers of arrays. And sometimes it can be 2, sometimes it can be 6, and even more. But a number function signature has a number of name parameters. Alright, I understand. Neither of this is flexible enough. You have to write a different function for every possible count of arguments, which is unworkable. Got it. So it B, C, D, A, F, G, etc. The rest parameters dot arrays. So it is by copying up all the arguments, however many there are, into a single array called array. So we have this all. No matter how many arrays we get in, they all land inside one variable. They all is gonna be land. What is land? Bro, what is definitely the land? Hola. Mhm. So the rest parameters, rest parameter is flexible enough. No, so it is by scoping up all the arguments. So it is up scoping all the arguments. However many there are. So no matter how many arguments there are inside of this, no matter how many are there, whatever, into a single array, call it array. Got it. So this is a variable into a single variable, call it array. We're almost finished up for today. We have just 10 minutes left. Alright, we have all of this. And the promise thing is I must have two or more not fixed numbers. So the parameter, the rest parameter, we're gonna put a rest parameter in arrays. So it's gonna be all the arrays that we have. So this is gonna be all the arrays that we have. So let me put this in the documentation. In arrays. So the sync array is gonna be like this. Arrays rest parameter This is the rest parameter. It can. Oh, okay. No matter how many are players, they all and yeah. Neither of this is flexible enough. You would have to write different. Okay. Have these functions. Rest parameter. Function. One for exactly two arrays. Neither of these is flexible. You have to write a different function for every counter of arguments, which is in one workable. The rest parameter solve this by scoping up all the arguments, however many there are, into a single array called arrays. And why use dot result reduce? Why do you use dot reduce on this? Once we have arrays a list containing some numbers of arrays, we need to combine them all down to a single answer using diff2 to combine two at a time, repeatedly left to the right. So we have A, we're going to resolve this, A and B. After resolving this A and B, we're going to have result 1 and result 1 with C, and result 2 with D, etc. So yeah. We need something that takes two items first and then combines them, takes that result and combines with the third item, takes that result and combines with the fourth item, keeps going until there's no items left. Hands back the final combined value. That's in a generic pattern. Now I'm starting to understand this complex things. It does. Yeah. A single answer. Using difference two to combine two at a time repeatedly left to the right. Difference two to combine two at a time. Repeatedly left to the right. It's gonna be A, B, C, and D. Etc. We're gonna need something that takes the first two items and combines them. Takes the first two items and combines them. After all, let me write it out. Why using that result? I just have just finished left. Should I try to finish this? I'm gonna try it. So, we have this exercise of symmetric difference. We're gonna try to solve it. We're gonna use a function first because let's see it here. We are counting a function. So function diff2, because first we need to receive the two difference of two arrays. So it's gonna be receiving like this. A and B, after receiving the values in A and B, we have the result 1. This is the first result, and we want to compare this first result with the C. So it's gonna be like this. We're gonna receive A and B. Inside this function, we're gonna have const set A, which is gonna receive the new set, the value of A, and const set A, const set B equals new set B, the value of B parameter, and we're gonna have a result of this because we're gonna compare. It's not compare, but we're gonna append all the values that are in B and A, and the values that are in B and A has to be different because we are taking the difference out and putting the result. So result is gonna be empty array, and for each value that is in A, it cannot be in B. So set A dot for each value. I'm gonna declare the variable. I'm gonna declare this variable. For if the value isn't in B, no. The value or not. Now, if set B doesn't have the same value as set A, so set B doesn't have the value that is inside the set A. That has value, doesn't have. After this, we're gonna print. No, it's not print. Gonna push this value to the result array. So value. It's not gonna be set A. Set B, we're gonna do the same thing. Now we just have 29 seconds. We just have 29 seconds to figure this out. Oh shit. Set B. This gonna be set A. After all this, we return the result. Ah shit! No. So for finish this out, we're gonna have another function for mistigate all the values and any number of arrays. So we have so many arrays that we can find. It's not can find it, but can count it. Like A, B, C, D, E, F, G. We cannot have so many arrays in these parameters. So we're gonna have a function synchronize. We're gonna synchronize all these arrays together. So we're gonna have the rest parameter, this rest parameter, and we're gonna declare array, call it arrays. So we're gonna have so many arrays like A, B, C, D, F, G, F, etc. And we're gonna return the arrays dot reduce. And why use the reduce? Oh my goodness. We're gonna use the reduce for I didn't remember why. For div2. For div2. So this reduce, like think about, we have 1, 2, 3, and 4 inside of array. We're gonna sum them out and it's gonna be 10. And this reduce is the 10. So we have 4 elements, and this reduce is gonna reduce into 1 element of this array. So all this 1, 2, 3, 4 sum out, and the result is gonna be 10. 1 element, not 4. We're gonna reduce all this into 1 element, so it's gonna be 1 array. So we have a couple of arrays, so many arrays, and these arrays we're gonna reduce them by 1 array. So, and what? I'm gonna test this. So I'm gonna test this. Console.log. Oh my goodness, what did I make it wrong? What I make it wrong, man? No. Should I put it inside this div 2? Oh man. No. Yeah. We are not finished for today. I just failed miserable.